C is defined as the sum of all the positive integers n such that n minus 6 is the second largest factor of n. What's the value of 11c? So when I did this question, one that popped into my head was 12 and 6. That's going to work, isn't it? Because 6 is 6 less than 12, but it's definitely going to be a factor because it's half of 12. And then the approach really then to take is to think, oh, could you get a larger value of n where it would work? And the answer is going to be no, because the second largest factor is never going to be more than half of the original number, because that's when you divide by 2, and you can divide by 1 to get the original number as the largest factor always, but then the second largest factor is going to be half of the number if it's divisible by 2, and less than that if it's not divisible by 2, if it's say divisible by 3 or something else. So I only need to check, this is what I'm trying to say, the numbers from 12 downwards. In fact, we can stop at 7 because 6, n minus 6 is going to be 0, which is not going to be a factor. And then for negatives, well, you might get n minus 6 as a factor, technically. Like 4 minus 6 would be minus 2, which is a factor of 4, you could argue. But it's definitely not going to be the second largest factor, so we can ignore that. So I'm left with, I've got 12 as 1, and then the second largest factor of 11, because it's prime, is actually 1. That's not going to work. For 10, it's going to be 5. Nope. For 9, it's not divisible by 2, it's divisible by 3, which is going to give 3. So that one is going to be okay, actually. That is a possible value for n. For 8, I've got 4, and then for 7, I've got 1, and that also works. So in fact, we've got 3 numbers where it's okay. We're asked to find, well, first of all, let's find C by adding these up. We've got 16 plus 12, 28. And then we're actually asked for 11C. So 28 times 11, that's going to be 280 plus 28. It's a little multiplication, 10 times 28 and 1 times 28. Add them together, it's going to give 308. Now, to be honest, I took a longer approach to get this solution. I'm going to talk about it just, because I think it's quite interesting to see the applications of this topic, because there's a question just like this in the Senior Maths Challenge is actually a little bit harder. So what I did is I wrote n over n minus 6, and I know that has to be a whole number because n minus 6 is the second largest factor. So if I just look at instead just n minus 6 being a factor of n, then I'm looking for the solutions of n over n minus 6 integer values when n is also an integer. And what the trick here is then to write it as n minus 6 plus 6 over n minus 6 becomes n minus 6 over n minus 6 plus 6 over n minus 6, which is 1 plus 6 over n minus 6. This is now more manageable because I've got 6 at the top rather than n. And so there's only a limited number of n minus 6's because it needs to be a factor of 6. Remember, n is also a whole number. So I can write down n minus 6 and 6 over n minus 6 and investigate. So n minus 6 could be 1, could be 2, could be 3, or could be 6. In fact, it could also be minus 1, minus 2, and so on. But that is then going to give me a negative n, which is definitely not going to be the second largest value of n. So I'd need them for the full solutions to the original, this problem here, but not to the original problem. I can ignore them. So 6 over n minus 6 is then going to be 6, 3, 2, and 1. But what I'm really interested in are the values of n. So for n, I'm going to get 7, 8, 9, and 12. And then I just need to check them. So right, 6 is the second largest factor of 12. So yep, I'm going to include that one. 3 is the second largest factor for 9. Actually, for 8, the second largest factor is 4. So I'm going to ignore that one. But for 7, 1 is the second largest. So I've managed to get my answer just in a slightly longer way using this method. Nice.